Welcome, everybody. Welcome.
All right, we're going to look at section 8. So we have scatterplots and linear models. So scatterplots may not be as familiar to you, but the linear model part, we're going to do stuff using slope-intercept form, which if you were in my algebra class, I know is very familiar to you. So, so there will be some common language that might feel a little more familiar than some of the things we've done. So here we look at this scatter plot. This is monitoring the consumer price index for a little over 5 years. There are 64 months. That's why there are 64 dots. That many different data points. And the independent variable in this case is along the x-axis, which is normally where that is. And here that independent variable is time measured in the months after January 2011. Okay. So very often that's going to be the time. It's independent because time keeps going, right? Time keeps going. We don't, you know, it's not depending on something else that's going to march on. And in this case, rather than it being like a date or a year that we're putting in, it's the number of months after January 2011. And the dependent variable is our consumer price index numbers. Now, obviously, those numbers, you know, have 3 decimal points at the end. So wouldn't that be fun to graph it, try to graph that exactly? And then everything here, so if we look at the ordered pair, so we've got one ordered pair that's actually on our graph. What that would mean is that 48 months after January 2011, which would be January 2015, the CPI was 233.707. And then we have some things about positive and negative trends. Also, we might see this called correlation, which we'll talk about next. But a positive trend is when, as one variable increases, the other variable increases. A negative would be when one increases, the other decreases. So kind of like positive and negative slope. If we look at this from left to right, we see that in general, it is going up. And so this is a positive trend. As time passes, the CPI increases, right? As the number of months increase, the CPI is also increasing. So here we have something called linear correlation. Linear, we know to mean straight line. And then correlation is a relationship between variables. And like that positive negative trend that we just talked about, positive negative correlation. But these are not going to be like a perfectly straight line because they're called a scatter plot, right? The stronger the correlation, the closer the dots are going to be to actually making a straight line. So you see some examples here: strong positive correlation, moderate positive correlation. The middle one, like no correlation, like someone just, you know, shot at it with a shotgun. It's just like spread out all over the place, random. And then moderate negative correlation. So again, from left to right as it's going down. And then a stronger negative correlation where it is nearly linear. They're all close together. And then what you see next is these are some trend lines. There's a whole different thing of math that we could do about creating those. We're going to have trend lines already given to us, so we don't need to worry about that in this regard. It does need to be said that correlation is not causation, okay? So just because as one thing's increasing, the other one is also increasing, does not necessarily mean it's causing it, all right? So you see this in social sciences all the time. It could be that there's a correlation between income level and smoking rate. It doesn't mean that having less, it could be a negative correlation. The higher the income, the less smoking. Doesn't mean that having more money keeps you from smoking. There's lots of things that go along with that. So correlation is just a relationship. Causation, there's actually the cause and effect of that. So now there are going to be some things in the relationship could also have some cause and effect. So the time you spend studying and your test score, chances are you spend more time studying, your test score is also higher. But we could know someone who studied lots and didn't have a high test score. The number of appliances in the home and the cost of an electric bill could also have positive correlation. Alcoholism and smoking could also have, as one increases, the other incidence increases. That does not mean it causes you to smoke. The weight of a vehicle and gasoline usage. So these are all things that have correlation, but then we have some other things over here that are really actually causation. They could also still be said to have correlation. Taking a test and earning points. You don't take the test, you don't earn points. Not paying your bill and then not having electricity. Smoking and lung cancer. And then there's all the debates. So as we see correlation, we start to investigate if there's also causation. And then oftentimes there's debate about, is this just happening together or is it something else maybe causing both? And then the barrel of oil and the cost of gasoline, the cost of oil, the cost of gasoline. So the trend line, also called a regression line, these are already going to be designed for us. Notice that is in slope-intercept form, where we have y equals some number x plus some number. Now, these are very precise with all these decimal places. So when we think about what is happening at different places, and in this case, this was computed through a computer program, not that a person ground it out to figure it out. So think about when something touches the y-axis, we know if it touches the y-axis, that is our y-intercept, and that 224.85, notice that it's the b in the equation that we're given. And if you find it on the left, on the y-axis, that's at 0 months, right? So that is at the beginning, at the start. So if they're saying January 2011 is the start, that's 0 months. Okay, so that is our starting CPI for January 2011. And where does that appear in the linear model, in the equation? That's the B. So when they talk about linear model, we're talking slope-intercept form equation here. And then the other part, we've got the 0.246 x. That number part represents our slope. That's our rate of change. So this is telling us that the CPI is increasing 0.246, or we could say about a quarter for each month after January 2011. So if I wanted to know what the value does the model predict for this time, I would put a 0 in because that's 0 months after, and it would be the 224.85 because 0 times 0.246 is just 0. So if we wanted to use the model to get an estimated value for February of 2011, what would we do? How many months after January 2011 is that? Yeah, so we would use 1 for x, with just this right? Plus the 224.85. Which came out to, I don't remember what that is. I guess I didn't write that. What did you come out with when you added those together? 225 point something. Okay, good. What if we wanted to know the CPI in January of 2016? What are we going to insert for X? 60. How'd you get 60? Exactly, because remember that the X is the number of months after January of 2011. So since it's 5 years, Randy did 5 times 12, and he's going to use 60 in the equation for X. So we'd have 6 times 60, and then we would still add on. Make sure my decimal's showing up there. So the actual CPI value in January of 2016 was 236.916. Does that fall exactly on the trend line? So no. And if you look at the picture, right, we can see from the picture, it's not exactly on the line. Also, if it's on the line, we would get that exact number that we just came up with. So the linear model is not going to give the exact. Now, there are a few points on that graph where it does give the exact, right? There's some dots that the line is going. If you found a dot where the line is going exactly through the center of the dot, then at that point, it does give you that exact number. But it's just going to give us an estimate. Because it's just the general trend that this is not a nice straight line. So we can use it to think about like estimating, like I could get an estimate of what it would be at this time. Now, if we start thinking ahead and trying to predict too far out, well, here's the problem though, is we get outside of the scope. So that's what, so the scope of the model refers to the range of values that we've been using. So it is not recommended that we go very far outside of this. So for instance, if, like my data ends in April 2016, if I wanted to try to make an estimate for, December 2016, early 2017, my estimate would probably be decent. If I want to use this, I don't want to use this and try to make a prediction for now. Too far outside the scope.
You think that it's been going that way 5 years.
But then now we're even 5 years beyond that. COVID happened, all kinds of things happened,
Right.
So
it's a strong trend.
But every piece of data that gets added, that line would change slightly. So just know if you don't see that within the graph that's shown, you would want to tell me that it's too far outside the scope. So in this case, the scope of the model from the graph, the scope of this model, well, it only goes through April 2016. So it would not make sense to use it for 2030. 2030 would be too far out. 2020, okay, maybe. But if we only have 5 years of data, going beyond 5 more years, we're too far. Too many things can happen in between then that the trend is going to change. So it's not going to be accurate. So every place on this graph has to do with the life expectancy. So kind of the average time that the average age of death, basically, the life expectancy at birth versus the GDP, the gross domestic product per capita. We did some work with GDP before. So we see that there are, so the US we see is like in the 60,000s, 60, 70,000, maybe 65, something like that. But we see like Qatar, Luxembourg, we're talking over 100,000 per capita. And then the higher the dot is the longer the life expectancy. So when you look at this graph, would you say that it is strong, moderate, or weak, which they didn't really show us a weak correlation? Now, because they've drawn a trend line on there, I'm gonna say it's definitely positive. Probably I would say probably moderate, because we got some people like Iceland that don't have, like, their GDP is really low, but look how long they live. I mean, yeah, like they're way up here, but their GDP is way down here. So we do have we do have several with low life expectancies and the low, but we also have this one's up here. And then if it was, imagine how long people in Qatar should live. If it was really strong, they would be like wherever this trend line is up here. So, and the trend line has been created, including all the dots that are on there. So I would say moderate. I don't know, we got a lot of dots far away. So someone could probably even make the case for weak, because we've got lots of dots that are far from the line. So our scope, how far out do we see? Looks like about $145,000. So thinking about the independent variable, how far out does that go? I wrote down about 145,000 per capita, GDP of 145,000 per capita. So then should we use the model to predict beyond 150,000? I'm going to say no. Like, we're getting outside already when we see the Qatar's number, that one is already far away from, that dot is far away from the line. So it's already showing that the trend line is not very accurate for someone in the 140s. In the 150s, we would end up with a crazy age of how long people should be living. And then if it asks what is the linear model, in this case, we've got the what is the linear model for number 4, and that is just simply what they have written there. There's our linear model. Number 3, we would say no, it's outside the scope. So if the number that it's giving you, if it asks, like, should we use it for this, and it's beyond what you can see on the graph, then I would just say no, it's outside the scope. Especially since the numbers closest to the end of the graph, the points there are not anywhere close to the line already. So if we know here, they're telling us that Luxembourg, their actual GDP per capita is 102,000. And to use that to predict their life expectancy. No, you're going to use the 102,000 as the life expectancy. So we're gonna do the 0.0, the 2/10,000ths times 102,000 plus 66.819. So we're just plugging it in, plugging that dollar amount. It says X equals, we're plugging that in to the equation. You guys come out with 87.2, a little over 87 years. Okay, and then it says, how does that compare to the actual life expectancy? So looking, we can't tell exactly, right? But if we follow that dot that's got the arrow to it that says Luxembourg, if we follow it over, how long are those folks living?
Low.
About 83, 82, right? So this, what the model predicts is higher than the actual life expectancy. How could you have predicted that your number was going to give you something that was higher than the actual? So when you look at the graph, the line that's on the graph, this line is this equation. That equation is the trend line. So if this is Luxembourg, I mean, this would be where, that should be the point that we're getting, right? When we plug into the equation, we're getting this. So we can see that the line is higher than the actual point. Okay, next page, get some nice slope action here. So looking at those two graphs, and think about what's the same and what's different about the two graphs.
Both have positive trend.
They're both positive. In fact, they're both perfectly linear, right? They're not just positive correlation. They're both linear. They're making nice straight lines. They both have the same scope. They both show up through, like we have 8 gallons as the bottom, as far out as it goes. What's something that's different about the two?
Stronger one, stronger.
No, these would, if I had to talk about the trend, these would both be strong positive because they're a perfect line. But what is different? Ones are for organic, one's 2%. Is the slope the same for both of them?
Would you say one is a stronger trend and the slope is?
Okay, a stronger trend just means the dots are closer to the line. It doesn't mean it's steeper. Steeper, we could say it's steeper. Yep, so the one on the right, the slope is steeper. The rate of change is faster. The bill is running up faster. Let's think about it. Organic milk, it's going to cost more, right? What about their y-intercept? Is that something else that's the same? They're both 0, right? So when we say where does each graph begin? We would say at 0, 0, right? 0 gallons of milk costs $0. So it begins kind of at the origin because there's no cost for buying 0 gallons of milk. And then why is the one on the right steeper? Because the per gallon cost is more expensive. And how much is the 2% milk? $3.30. How'd you get that?
2.
right between 0 and 2, we've got 330. Or if we use the 2 and did 660 divided by 2, we would also get 330. Good.
20 divided by 4. So
Yes, you could take any point on the graph because it's going through 0, 0. So then how much is the cost for, yep, $6.49, good, for our organic milk. Now, you could, because this is going through 0, 0, we can just divide. But if it weren't going through 0, 0, what if we were buying gallons of milk and 1 loaf of bread? Then it would not be at 0, 0, right? Then, like, for 0 gallons of milk, we'd still have the cost of a loaf of bread. Then we'd have to actually use 2 points. And like it says at the bottom, you could find how much the Y changes, find how much the X changes. But in this case, because it goes through 0, 0, the whole slope formula, we would not have to take those 2 and subtract. We could just simply do a division. But we can always take 2 points. Remember that to find slope, you got to subtract the Y's on the top and the X's on the bottom. So, this is just what I was getting at. So here we purchased some other groceries and some gallons of milk. So where does this line begin? So at 0 and 54, right? $54. So at 0 and $54. What does this mean in the context? Okay, yep, I'm going to put together what both of you just said. So the total price of the groceries with no milk, right? Without buying milk, or with buying 0 gallons of milk, is $54, which means the other groceries we're buying are costing $54. Before we get to how many gallons of milk we're buying, the other things we're buying are cost $54. Now, if I wanted to know how much a gallon of milk was, it would no longer make sense for me to do like, I'm just going to take that 60/60 and divide it by 2, right? That doesn't work anymore because of all those groceries. That would way overestimate. So in this case, the y-intercept is really what we just said, the $54. And on the other side of the page, our y-intercept was 0. And then down the bottom, they're going to take us through finding our slope, which in this case does turn out to be our 330 again. So here, if I wanted to find the slope, I could just subtract points that are right next to each other. So for instance, the fact that 5730 take away 54 and 1 take away 0, which gives me $3.30 for 1 gallon. But I could have used 2 other points. I could have used the one for 6 gallons and 4 gallons. I would have subtracted and got 660, but I would have had to divide by 2. So our slope is our 330. No, I was saying like if I used, say like 4 gallons and 6 gallons. So if I would have used 4 gallons and 6 gallons, picked any 2 points. If I did 73.80, take away 67.20. And then I could do 6, take away 4. And it's still gonna be 660 divided by 2. It's still 330 a gallon. So just kind of showing, if you can pick 2 points that are right next to each other, then you really don't need the division step because it's just a 1. But if you don't have points that are right next to each other, you can use any 2 points. If it's linear, they're going to be the same. The slope's going to be the same, that rate of change. So this is 0.54. And we could just write 3.3 instead of 330. So this would be our equation. So you're going to feel like on this next page that you're back in Algebra 1. And for some of you, that might be like, whew, a refreshing break. So it just reminds me of some couple of word problems that I had to do. And they're going to kind of drag this out of you. So some of you are like ready to probably just jump to E. So if David weighs 240 pounds and he sets a weight loss goal of 2 pounds per week, and X is the number of weeks, what would Y represent? The weight. And what units would it be in pounds? Good. So his weight in pounds. And then X, we already said, like it already said that up here at the top, but X is time in weeks. Because they already said at the top what he wants to weigh after X weeks of the plan. What would the y-intercept be, the starting point? £240. That's his starting point, right? That's his starting weight. And then what is the slope? So we want it to be -2 because we want it to be decreasing. So as X increases by 1 week, we want him to lose 2 pounds. So it is decreasing. So if we want to know how much he should weigh at any point after he starts the diet, then we should be able to take -2 times the number of weeks and add that on to 240, which basically means that number is going to subtract from 240. Okay, so for number 5, we have a little graph. Oh, I'm not on number 5 yet. Never mind. That was just E. So number 2, how much would David hope to weigh after 4 weeks? So what are we doing with the 4? We're plugging it in, right? So we plug it in. Yes, you should get 232 pounds. So the weeks, that's our X. So if I know the weeks, I'm just going to plug that in. And I also got 232 there. And then we're going to do the same thing for 10 weeks. So after 10 weeks, David's down to 220 pounds. So David's goal weight is 180 pounds. How did you get 30 weeks?
10 weeks and 10 weeks, 20 pounds. So another 10 weeks would be 40 pounds. Another 10 weeks would be 60 pounds.
Okay. How did you think about it, Randy?
I put 180 as the y to solve the equation.
There we go. So Mohammed kind of reasoned through it using the numbers we've already used. And Randy said, hey, we wrote an equation. If I want to know how much, when he's going to weigh a certain amount, I can put in 180 and then solve the equation. Did you also get 30? Yeah, good. So both ways. Now, had we not already found the 10 weeks, then the equation might be more efficient. But yes, if we've already thought about 10 weeks and it's a nice like we can like basically triple that and do that math, kind of easy math in our head. So now you're going to finish the graph. You only need to give me points. You don't need every single point. They've given you a couple, but find points for 5 weeks, 10 weeks, 15 weeks, 20 weeks. So all the 5s. Notice that we're stopping at 30 weeks. After you have substituted a few of those in, you probably start to notice a bit of a pattern on the graph. And because it is a linear function, I could just continue to use that pattern. That basically he's losing 10 pounds every 5 weeks. Because that's what our graph is showing, like the way the units are, that it's going down 10 pounds for every 5 weeks, which is -2, right? Down 10 over 5 is -2. What would change in the model and how would the graph change if David raised his weight loss goal to 2 pounds per week? What would
Steeper.
it would be steeper? Yeah, the graph would be steeper. Good. And the slope would change to -3. So we would have more like -3x plus the 240. Is it reasonable to assume that David could stick to this weight loss indefinitely?
No.
No, we don't want David to do that. He doesn't want to keep losing past his goal, which is, of course, in this case, why we stopped it at 30 weeks. Yeah, we're not trying to kill David off. All right, we're gonna skip over to the page that says breaking even, if that's still the order I have this in. I think that's just some. So yeah, there we go. Okay, so we're gonna make a linear model. So when you see in all this material, a linear model, think slope-intercept form, all right? So a linear model, and what would X and Y be in this situation? Okay, so, well, let's think about exactly So that's gonna be, you're down at number 3. That 90. So 90 is the B, but are they starting with a profit or loss?
Okay, so
They're starting with a loss, right? Like if they don't sell any, so we would want to make our B negative 90. So what is our Y? If X is the number of shakeups they're selling, what is the Y then?
we,
No, the Y is going to represent, what are we looking for here? The profit or loss. Yeah, Y is going to be the profit or loss. How would we know if it's a profit or a loss? Yeah, if it's a loss, it will be negative. Okay. The slope, so if I said X is the shakeups, that's the 3. Is it positive 3 or negative 3? Positive, because it's money they've got coming in, right? It's money they're making. Now we're just going to put this information together to write their equation. So I'll have Y is equal to 3X minus 90. So I might sell 100 shakeups. That would be $300, but I got to replenish the $90 we spent on the supplies. So we would actually profit 210 in that case. So look at number 5. They've said this is enough material to make 225 shakeups. So how much money will they have raised if they sell all 225?
I mean,
585. Good. So the 225 would become our X. We would multiply it by 3 and take away the 90, leaving them with 585. How many would they have to sell to raise $300, to have $300 profit? How many?
130.
130, yes. And so if we know how much money we want them to have, we're going to replace the Y and then solve for the X. So we just replace the Y with the 300, go back to using X, do our 2-step equation to solve that. Shakeups. Now, at the top of this, it said breaking even, all right? So the break even point is like where you don't make money, but you don't lose money. Like you made no profit, but you just barely covered, you just covered your costs.
So you sold $90.
So basically that means that the Y is 0. Yep. So if we let the Y be 0, that's the break even point where we're not losing, but we're also not making money. Which basically in this case, we might more intuitively know that that means, oh, I got to cover my the $90. So 30 shakeups. So if they sell less than 30, they lost money. Exactly 30. They at least broke even, only wasted their time. So if they wanted, you know, depending on what they wanted to raise, they said, we really need to raise $500. Well, then they're going to have to, you know, sell nearly as many as they have, use up almost all of their stuff. Because if they use up all of what they said, they have enough materials for 225, and that was only 585. Okay, so here Now, I'll tell you one point that where people got a little confused last spring was because we had done relative change and then we did slope. Relative change, we subtracted and then we divided by the original. Slope, we're trying to find how much is it changing per year in this case. So we have to subtract the dollar amount and find out how many years in the bottom. So with slope, you're still subtracting Y's and X's, just like when you did slopes before. So in this case, cigarettes, this is quite a change since 2000. 3 take away 1, and then 2000 take away 1980. So $2 over the course of 20 years. Good. So I get 0.10. So this would be 10 cents per year. So cigarette prices have increased an average of 10 cents per year. Now, this is pet peeve for Carolyn. If you were writing that and not writing out the word cents, you can do this with a decimal point. You can do this with a cent sign, or you can use the word cents. Do not use the decimal and the word cents, because then it would mean 1/10 of a penny. Okay, and it's 1/10 of a dollar, right? So I know you see it in stores all the time, but there should not be a decimal. When you see that sign at the grocery store that says that bananas are this price, you should be able to take like over 2 pounds of bananas up there and give them a penny and walk away, because that's saying it's less than a penny a pound. I haven't tried that, but
Wouldn't that technically be false advertisement if they didn't give it to you for that price?
I know, that's what I mean. There was an actual story that happened about, it was when there was more per messaging rates, and there was like something, it was supposed to be like 2 cents, but the way it was written, it was at the, would have been the 4th decimal, because it said 0.02 cents. And so a guy was like, why are you charging me so much? This isn't. And he actually did like win, so that he didn't end up having to pay some crazy bill. All right, so if we're doing a linear model that predicts the cost of a pack of cigarettes after 1980, so the X would be the number of years after 1980. And then how much was the cost in 1980? So we put +1. Because that's basically our 0 time for the problem. Okay. So then let's use this to estimate what the cost of a pack of cigarettes is today. So we are 42 years after 1980. So that would be $4.20 plus $1. That would be $5.20. And most smokers would be happy if that's how much they cost, because I think they're
It's like $8.34 per pack of cigarettes.
yeah. My mom is a smoker and it drives me crazy. And recently she just ended up moving. She's in the process of moving because her housing situation, she was in some place that was income based, and then they changed it to not being income based. And so her rent went up like $250 a month. So my brother is like sending a text to all of us saying like, how can we help mom? Blah, 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 blah. And guys, you can think I'm a hard ass, but the first thing out of my, but I was like, hey, the elephant in the room here is, what about smoking? If she can still afford a pack a day, there's $200 a month. If she can, yeah, if she can still afford a pack a day, she's not, money hasn't gotten to, I'm not saying it's easy to quit, but if she can still afford a pack a day,
If she does go to the plus 4 or 5 times that. Yeah, it's like $12. Well, it's like $20, so $25. Yeah, New York. I was in Chicago with a friend of mine. He got a pack of cigarettes for like $16, I would say. Yeah.
Yeah.
Except the taxes.
yeah, then, well,
But still, I mean, $16.
it's a deterrent thing. Maybe at that point, maybe it's a deterrent. I don't know. So anyway, so I'll get off my anti-smoking soapbox for now. So, so what would this, how would we find the slope here for this city? Remember that time, like the years, is going to be our independent variable. So we're going to, that means that's the X, that's going to be on the bottom. Because this dropped, right? So we should come up with a negative number. So our 450 in 2005, subtract 4,800. That would be on the top. And then on the bottom of that, we've got our 2005, subtract 1,900. My usual system is not cooperating. So I have negative, which makes sense that it's negative because we know it's decreasing. 4,350 divided by 105. And I know like when we're making a graph, we are typically, if we're making a graph, we usually leave it in a fraction form, but we're going to use a decimal for these because we're plugging in, that's going to be easier. So like negative 41.43. So that's my slope. And then if I'm going to write my linear model, I would have y equals, then I insert my slope. And an x. And then what would our b be? What's our starting point in this case? The 4,800. Now notice when we talk about, like, we do not put, when we do the C, we're not going to put 2015 in for X. Maybe no one was tempted to do that. Remember, it's how many years after 1900 it is. So how many years after 1900 is that? 115. So use 115. How many people did you come up with? We'll round it to the nearest whole person.
$36.
36 people. Hello. That's what I figured. Could this continue indefinitely? No, we can't have a negative number of people, right? We can't have a negative number of people. Okay, I want us to go all the way back. There's a few pages. Go back to look at the homework pages. Okay. Oh, did anyone have questions from yesterday?
I did, but I got returned mine at the beginning of class. Do I need to get it?
No, just to do, no, I meant like go to the homework pages for this, but I had said if to try the problems and let me know if you had questions. So that's why I was checking if you guys had questions about those now that I was thinking about it. Okay. All right, so go to the end of section 8. And we've got some questions first that are scatter plots. And we may tomorrow spend some time going back over some more of these examples. I'm hopeful that maybe Maya will be able to be back with us tomorrow. Hopefully she'll be feeling better. But hello, nice writing all over everything. Here. And then she could be here and we'll go through more of those things together, but we can go ahead and look at the all right. Now, for some of these, like, so in this case, notice it actually has the years at the bottom. It does not say how many years past a certain date. So this was my question as I started working through these materials myself, was just how do I know if I should be plugging in like 50 or if I should be plugging in 1,800? Do you guys see what I mean? Like, so if I plugged in 50 to the equation, because 1800 is 1750, 50 after 1750. If I plugged in 50 to the equation, I would not get this point. Like, this is my trend line. I would not get this point. You see what like, so if I'm uncertain, or like I say, like, okay, did they just use 1800? Well, if we put 1800 in here, we can confirm that that's how they're getting the trend line. So someone type in your calculator 0.0478 times 1,800 and then subtract 77.063.
8.977.
How much?
8.977.
8.977. Is that reasonable for where this line is touching?
Yeah.
Yeah, because it's below 10, just below 10. So now we know we actually put the whole year in there, not just how many years past 1750. So the slope for this trend line, if these are the years, the slope for this trend line might be written as something like, as far as what does it mean, that there are 4.78 stars discovered every 100 years. Okay, so think about so if I move this over 2 places, because that would be hundredths, right? So I could say, or I could say 478 stars discovered every 10,000 years. Because it's 10,000th place. These are the new stars discovered. So someone could tell me 4.78 every 100 years, 47.8 every 1,000 years, or 478 every 10,000 years. But it is new stars discovered for that many years. I mean, you could say 0.0478 stars per year. That would be for 1 year. That would be the same thing. So some of these are going to sound kind of clunky if we use just the thing, but that's what we're given. It's going to, because it's so precise. So if I want to know what value does it predict for the number of new stars in 2020, then we're going to put 2020 in for X. How many new stars did you guys come up with there? So just to the nearest whole star, how many do you think? So about 20 stars. And then would it be reasonable to make predictions for 2050 or beyond? Maybe I should even say beyond 2050. 2050 is getting to the edge of our scope here, right? It's getting too far away. We only have information for, it looks like about till 2010. So 2050, we would still be okay. If we go beyond what's, if it's beyond what you see on the graph, then you would want to say it's outside the scope. Okay, look at hey, this is a nice fall thing. The next one on the next page we have is, what would the slope mean here? I don't feel like this tree has that many leaves compared to a lot of trees, but so the slope here, I could say the cedar tree loses 16.42 leaves per day, or loses about 16 leaves per day. In the fall, right? In the fall, because this is days after the start of the fall season.
How many leaves?
Look at this slope.
Yeah.
That's how many leaves. The 16.42. That's how many it's this. So you're going to use this number when it's talking about slope. You're going to use this number, and then leaves per day after the fall season. And if the bottom was months, we'd say for months. If it was years, we'd say for year. And then we can just use a word like loses, or over 16 leaves per day fall from the cedar tree, something to indicate that it's negative. So how many leaves would you expect to see on the tree after 18 days into fall? Where are you gonna put the 18? And then you still have to add the 488. Yeah. And how does it compare then? The dots are not the dotted line, but the dots are the actual numbers when they counted. By the way, reminder that today they are giving flu shots and COVID shots, so get your vaccinations over at Ivy Tech if you're interested. I'm going this afternoon. I have not grown horns or anything else from my previous vaccination. Some of you might think I'm the devil herself, but I have not.
They have boost.
Yes, you can get, yeah, I'm getting my second booster. Boost is like in a video game, it can boost up.
You get the side effects from the first boost. Sore arm.
I didn't have any issues. I mean, yeah, someone jabbed a needle in my arm, probably even if they didn't give me anything, I'd feel like that.
First vaccine, that was.
You had, oh, wow, I didn't have any.
Yeah, the first nurse who tried it, like, broke down and fainted on live TV. It was kind of bad.
Yeah, no, I didn't have any side effects from my other one, so I don't expect that like that means you're gonna get a day off tomorrow or anything. I was just like letting people know in case you wanted a flu shot or a COVID booster or whatever, you have the option. It's free. You don't have to, they will ask you about your insurance, but if you just say, I don't have it with me, they'll just give it to you anyway. I mean, for real, I'm always afraid, like, I'm gonna go to one of those things and then they're gonna say like, oh, your insurance didn't cover this. So I just say, I'm sorry, I don't have that. Oh, okay. So. All right, turn to skip a page. You don't need to worry about the page in the middle. Look at these job opportunities. So what do you think the slope for this graph means? No, so did you go to this one? Skip that one. Yeah, skip the one that the very next one. So every year, what's happening, Jess? Very good. So she said every year there are about 149 less job opportunities at company Z. So notice, like, you're gonna use, if it's talking about slope, you're using this number in front of the X. And then you're gonna use, like, these are years, so that's why we can say for every year. Or, and I mean, if you want to say, the job opportunities at company Z are decreasing by 148.82 per year. I mean, I think, we can take some liberties and say about 149, but you can use that exact number. We would want to just say they're decreasing by this and not say per year, because then we don't know, like, oh, from since 1990 to 2015. And then in which years would you say that the prediction is about the same as the actual? How would we even know that? Do we have to go through and do the math for each one?
With the trend crossing in the middle of the dot.
Yeah, if we see the trend line is actually going through the dot. So there's some that are really close. Like maybe 91's pretty close, 93, but 2001, oh, pretty close there. 2010 looks like spot on, right? 2014. 2016. So any of those, like I would accept any of those answers where the line, I mean, it doesn't have to be exact, but where it's very close. So perfectly through the center of the dot would mean the calculation should give you spot on. And then this problem on your next page, some of these are like your, so that's like the lemon shake-up problem. And remember, break even would mean let y equal 0. Rate of change is the same thing as slope. So when you read number 2, and it says, find and interpret the rate of change for rent in Columbus, you still want to subtract the money on top and subtract the years on the bottom. So tomorrow will be day 2 to talk about linear models, scatter plots, and then have some time also to work on this. Please have a bagel, Panera bagels back here. I do also have strawberry and pumpkin cream cheese if you want cream cheese on your bagel. Some of these are like pretty sweet by themselves. There's also some that are Asiago cheese that are more of a savory if you're not a sweet person.